Hello everyone and welcome back to the channel. So today we are going to see the topic of bridge rectifier. Last video we have seen center tapped rectifier both or the classification of full wave rectifier. So for building the bridge rectifier, what are the needs we will be having? That is the AC input will be connected to a transformer T. AC input connected to the primary of transformer T, and the secondary of the transformer is connected to the diodes D1, D2, D3 and D4. These diodes are connected in such a form like a Wheatstone bridge. They are again connected to the load resistance RL, from where the DC output will be drawn. So that's what I may written here. The circuit for bridge rectifier contains 4 diodes D1, D2, D3 and D4, arranged as shown in the diagram in the form of Wheatstone bridge. End A is connected to the S1 and end C is connected to the S2 of the transformer T. That only end A is connected to S1 and end C is connected to S2. Primary of the transformer is connected to the AC input. So okay, since we are taking for the AC input, there will be both positive and negative half cycles. During the positive half cycle of AC input, say end A is positive and C is negative. Now diode D1 and D3 conducts current in the direction A, B, R, L, D, C, S2, S1 and A. At this point, diode D2 and D4 does not conduct current. So what they are explaining is, let us consider since it is an AC input, there will be both positive half cycle and negative half cycle. I am denoting positive half cycle in the black color and denoting negative half cycle in the red color. So okay, when so end A will be positive. So when end A is positive, the diode D1 and D3 is forward biased. So the current will flow. I will trace the direction. A is positive. Here it will pass through the D1 because this is a positive end of the diode D1, so it is forward bias, so it will pass through D1 and it will pass to the load resistance in this direction. Then it will go through it will reaches the point D. At this point D, it will go to the point here. It is forward bias, so it will reach to the C and it will flow in this direction. Okay. For a positive half cycle, these are the things. For the negative half cycle, the end A will be negative and here C will be positive. In this time, the current will flow in the direction like here. It will flow in the direction the same thing. It will flow like this. So if you notice, during both the half cycles, the current flows through the load resistance in the same direction. So that's what they are trying to conclude. If we see during a positive half cycle, the load direction is this A, B, R, L, D, C, S2, S1. A, B, R, L, D, C, S2, S1. A, B, R, L, D, C, S2, S1. That in that direction it is going to flow. During negative half cycle of the AC input, current flows to the direction diode D2 and D3 in the direction CB, RL, D, S1, S2, C. Here end A is negative and C is positive. Diode D1 and D2 does not conduct current, same as we have seen. Conclusion, since we conclude that in both positive and negative half cycle, current flows in the same direction through the load resistance. Thus DC output is developed across load resistance and we have a full wave rectifier. Okay, that's all for today. If any doubts, comment below, and if you want any topics also, you let me know. Okay, thank you.